Hello and welcome. In today's video, I'm going to run through the routines which are involved in picking a physical device. Let's jump in, have a look at it. So the first thing I'm going to do is I am going to set a class member to store reference to the physical device. And then I'm going to create a function called pickPhysicalDevice. The way this works is, first of all, we grab all of the physical devices that our system has. Most systems should just have one, the graphics card. However, we might be working on a larger system with multiple graphics cards, and we can actually get multiple graphics cards running together. I mean, that's possible. Okay, so we do the standard routine to enumerate through something, which is we call it once with a reference to an integer to get the number of things, and then we run it again. We create an array to store all the elements, and we run it again, pass in the empty array, and it populates the array. Okay. Then what we want to do is we want to loop through all of our devices which we have. Again, for my system, probably just one device, the graphics card. Check if it's suitable. If it's suitable, then we set our physical device to that device, and we can exit. And then at the end of this, if we didn't get something, then we can throw an error. Okay, so there is a bunch of ways that we could pick whether a device is suitable or not. And I'm working with quite a simple routine here, but it's based around something called Q families. So, what is a Q family? Well, everything in Vulkan is done with what's called a queue, and that's like we want to get a task done, and there's a bunch of little mini sub-steps involved in that task, and all together that's called a queue. The three major types of queues are graphics queues, compute queues, and transfer. So graphics, we understand what that is. That's just, doing all the graphics sort of stuff. Transfer is copying memory from one location to another, because we might want to get things, right down close to the metal of our graphics card. We need a different sort of operation to do that transfer. It's transferring memory, basically. And compute, well, you know what that is. It's doing computations and things. I think there's another one off the top of my head, present. But present is drawing things on screen, although that might be more to do with swap chains. We'll see. We'll see. But for now, the only thing we care about is graphics. We just want to grab a device which is able to support graphics capabilities. Cool. So in order to do that, we need a Q family which is set up for graphics. Let's jump in. So let's go up the top. I've created a structure called Q family indices, and what we want to do is find the index of the graphics Q family within our video card. And if it's there, then it will be a number. So let me just jump in down here. Okay, so we want to call this find Q families. That returns a set of all the Q family indices. Okay, so the way this works is we create a struct up here, then we loop through the physical device family properties, and what we're checking for, so this tells us all of the Q families that the device has. There's a whole bunch of them. For instance, let's say we have a video card which supports graphics, transfer, and compute. Well, it will also have it'll have one Q family which does all three of those. It'll have another Q family which just does graphics, another Q family which just does transfer, then another Q family that does graphics and transfer. Gets a bit weird. But what we're doing here is we are finding the first one which supports graphics. So we do a bitwise and if the graphics bit is in the Q flags, then it will succeed. And if the graphics bit is not in the Q flags, then it will fail. So long story short, this just gives back the first Q family which supports graphics. So we set that value, and then we have this check to see if the value has been set, which at the moment is quite simple, but it will get a little more complicated in future videos. And then we return the set of indices. So if we run it, if we have a graphics card which for some reason does not support graphics, then it will run through this loop and it will return a set of indices where the graphics family has not been set because there's no Q family index which supports graphics. You see what I mean? So if we go back here, that's what we're checking here. So we get those Q family indices, and then we check if, all of the indices that we're after have been set. That's the is complete. Now I've sidestepped this a bit. How do we check if it's complete? Well, we could use a sentinel value, for instance, set it to a negative number. If if there's no suitable graphics family, set graphics family to a negative number, but that doesn't work so well because this needs to be unsigned, a uint. So a C++ solution here is the optional functionality. So we have to go include optional up the top. And what optional does is normally when you use normally when you use a structure and you don't set a member, then the compiler complains, rightfully so. However, if we give it this optional type, then the unset state also counts as valid. So this thing can be set or unset. And furthermore, we have a test function to see whether it has actually been set. So this is a cool way to work with this without having to worry about sentinel values or stuff like that. Hopefully that makes sense. Okay, so let's just run this and check that it's working. And I suspect, oh, okay, that's cool. It works. And we have some stuff. So this is actually, all of this stuff is validation, but it's really just logging the minutia of what's going on under the hood. Because remember, we included verbose in our validation layers, so any sort of trivial information is also being logged as well. But yeah, okay. Cool, so that's it. Over the course of this video, we've had a really quick tour of how to check the powers of our graphics card and check that we've got a suitable graphics card selected. Yeah, that'll be it for now. As always, the the code is in the description of the video, so you can dive in and have a look at it. All right, have fun. Bye.